the initial vectors are S1 and S2, and the initial cost of this S1 is 0 and S2 is also 0, and here it is Zj, and delta J is equal to Zj minus Cj. All the values in the last row are positive, greater than or equal to 0. If delta J is greater than or equal to 0, then the optimality is reached. To convert this key element as 1, divide the entire row by this key element. So that means divide this second row, R2 divided by 2. Hello dear students, welcome to this session of our class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session I am going to discuss regarding the very important method, that is finding the solution of LPP using Simplex method. In the previous class I have discussed one problem based on this. Today also I am going to discuss the same concept, that is solve the following LPP using Simplex method. Solution of a linear programming problem using Simplex method. Now what is the problem given? This is maximization. Max z is equal to 7x1 plus 6x2 subjected to the constraints x1 plus x2 is less than or equal to 4, 2x1 plus x2 is less than or equal to 6, where x1 and x2 is greater than or equal to 0, that is non-negative restriction. So the objective function is maximum z. Now what is the constraint? The constraints are x1 plus x2 less than or equal to 4 and 2x1 plus x2 is less than or equal to 6. Now so let us convert this into the standard form. So for this maximization problem, we are going to add two slack variables, that is S1 and S2. By adding the slack variables S1 and S2, this can be written as the equation reduces to max z is equal to the objective function maximum of z is equal to 7x1 plus 6x2. The initial cost of the variables S1 and S2 is 0, 0 S1 plus 0 S2. Subjected to the constraints, what are the constraints? x1 plus x2 is less than or equal to 4 is converted into x1 plus x2 plus s1 is equal to 4. So converting these inequalities into equalities, we are going to add the slack variables s1 and s2. So x1 plus x2 plus s1 is equal to 4, and the second equation 2x1 plus x2 plus another variable s2 is equal to 6, and the non-negative restrictions are, as you know, x1 comma x2 comma s1 and s2 are all greater than or equal to 0. Okay, now this is the standard form of the given equation. Now let us go for the first simplex table, that is construct initial simplex table. Now let us construct the initial simplex table. Before going to that, let me write the coefficients of x1, x2, s1 and s2 and check whether it will form an identity matrix or not. So x coefficient of x1, x2, s1 and s2. The coefficient of x1 and x2 for the first equations are 1, 1, s1 is 1 and s2 is 0. And for the second equation it is 2, 1, s1 is 0 and s2 is 1. So since it forms an identity matrix, this is an identity matrix with these two slack variables s1 and s2. Now let us construct an initial simplex table. In the initial simplex table we are going to use s1 and s2. So here initial vectors are s1 and s2, and the initial cost of s1 and s2 is 0 and 0. The initial vectors are s1 and s2, and the initial cost of this s1 is 0 and s2 is also 0, and here it is zj, and delta j is equal to zj minus cj. Now here write down the coefficients of the basic variables x0, x1, x2, s1, s2, and the ratios. The coefficient of x1 is 7 and x2 is 6, and s1 is 0 and s2 is equal to 0. That is from this max z is coefficient of x1 is 7, x2 is 6, s1 coefficient is 0, s2 coefficient is also 0, 7, 6, 0 and 0. Now write down the coefficients of the constraints x1, x2, s1, s2 of the constraints. Now from the first equation For the first equation, what is the coefficients we have? 1, 1, 1, 0. That is 1, 1, 1, 0. And for the second equation, 2, 1, 0, 1. So 2, 1, 0, 1. 2, 1, 2, 1, 0, 1. Here, the values of x naught are on the right hand side, that is 4 and 6. Here it is 4 and 6. Now, find out the value of zj. You know how to find the value of zj. Just multiply this. 0 into 4 plus 0 into 0. 0 into 6 is 0. Again 0 into 1 is 0 plus 0 into 2 is 0. Again 0 into 1 is 0 plus 0 into 2 is 0. Okay. Now again 0 into 1 plus 0 into 0 is 0. Again 0 into 0 is 0 plus 0 into 1 is 0. So initially, for initial simplex table, the value of zj is always 0, 0, 0, 0. Now find out the value of delta j. What is delta j here? Delta j is equal to zj minus cj. Now zj minus cj. 0 minus, this is 0 minus 7. 0 minus 7 is equal to minus 7. This is minus 7. Again 0 minus 6. 0 minus 6 is minus 6. This is minus 6. 0 minus 0 is 0. Again 0 minus 0 is equal to 0. Now here identify the least negative value. So in this delta j, that is zj minus cj row, identify the least negative value. The least negative value here is minus 7. Okay, so therefore this is called an incoming variable. These are called incoming variables. So this column is called incoming column. Okay, listen to me, the initial simplex table. So write down the coefficient initial vectors. Initial vectors are s1 and s2. The coefficients are s1 is 0, s2 is also initial cost of s1 and s2 are 0. And write down the coefficients of x1, x2, s1, s2 on the top, 7, 6, 0 and 1 from the given objective function. And the coefficients of x1, x2, s1, s2 from the constraints, that is 1, 1, 1, 0, 2, 1, 0, 1. And again the ratios, that is the values of x naught are on the right hand side, that is of the constraints 4 and 6. Now find out the value of zj. Zj is nothing but just multiply these two. 0 into 1 plus 0 into 2. So what you are going to get? 0. Again 0 into 1 plus 0 into 1 is 0. So usually you are going to get 0, 0, 0 z in the zj row. Now find out delta j is equal to zj minus cj. This minus this. 0 minus 7 is minus 7. 0 minus 6 is minus 6. 0 minus 0 is 0. 0 minus. And identify the least negative value in this row. So in delta j, just find out the least negative value. So here the least negative value is minus 7. Minus 7 is the least. So therefore this is called an incoming variable. Incoming values or incoming variable, or you can also call it as a, since this is a column, incoming column. So let us mark this. Okay. Now find out the values of ratios. The ratios here, since this is x1 and x2, x0, therefore the ratios are x0 divided by x1. x0 divided by x1 will give the ratio. So this is x0 divided by x1. So x0, 4 by 1 is equal to 4. Again 6 divided by 2, 6 by 2 is equal to 3, and that's it. Okay. So identify the least positive ratio here. The least positive is plus 3. So this is called an outgoing variable. So outgoing variable. These are called the outgoing variable. So here that is x1 is incoming and this s2 is outgoing variable. Now what is the key element? The intersection of the incoming values and the outgoing values is nothing but the key element. So the intersection of this incoming column and outgoing row will give the key value. So here the key value is 2. The intersection of this row and column is the key value. In this the key value is 2. So key value is equal to 2. Key value is 2. Now for the next, since here we have negative and therefore optimality is not reached, hence we have to go for the next iteration, that is the first iteration. In the first iteration table, what are the things we are going to do here? First of all, x2, this x2 is replaced by the incoming variable, that is x1. So x2 is replaced by x1 and the coefficient of x1 here is 7. Okay, and the next step is convert this key value, key element as 1. So to convert this key element as 1, divide the entire row by this key element. So that means divide this second row R2 divided by 2. R2 is equal to 6 by 2, 2 by 2, 1 by 2, 0 by 2 and 1 by 2. And again convert this element as 0. Okay, so there are two important steps. The first step is convert the key element as 1 by dividing throughout by 2, and above this key element convert this element as 0 using the proper elementary row operation. That's it. Now let us come to the first initial simplex table, that is first iteration. So here what are the things we are going to do? So here S1, S2 is replaced by S2 is replaced by the incoming variable x1. Okay, and again convert this key element as 1 by dividing the entire row by that is R2 dash is equal to R2 divided by 2. That is, what is R2 here? 6 2 6 comma 2 1 0 1 1 0 1. For this we are going to divide throughout by 2. So this is equal to 3 1 1 by 2 0 and 1 by 2. Okay, so this is the new row R2 dash. So this I am going to put it in a new row R2 dash. So this R2 dash is equal to, here S1, the coefficient of S1 is 0 as it is. Here S2 is replaced by x1, that means the outgoing variable is replaced by the incoming variable x1 and the coefficient of x1 is 7. So for R2 dash we obtain, we are getting these elements 3 1 1 by 2 0 and 1 by 2. So this is 3 1 1 by 2 0 and 1 by 2. This is the new row. Now convert this element as 0, that is convert this element as 0 by using the proper elementary row operation. Okay, so to convert this element as 0 we are going to use the operation R1 dash is equal to R1 minus R2. What are the elements in R1? The new elements. So that is R2 are 7 3 1 1 by 2 1 0 and 1 by 2, whereas the elements in R2 are, these are the elements in R2, that is 4 1 1 1 0. So I will write here 4 1 1 0 again. This is elements of R1. The elements are 3 1 3 1 1 by 2, again 0 and 1 by 2. Subtract this, that's it. So this is R1 and R2. So R1 minus R2, this minus this, subtract this. 4 minus 3 is 1, 1 minus 1 is 0, 1 minus 1 by 2, 1 minus 0 is 1, this is minus 1 by 2. 1 0, 1 minus 1 by 2 is 1 by 2, 1 and minus 1 by 2. Subtract this, R1 dash is equal to, this R1 dash is equal to R1 minus R2. What is R1? R1 is nothing but the values from the initial simplex table. First row 4 1 1 1 0 and R2 are nothing but the elements of the first iteration, row 2 3 1 1 by 2 0 and 1 by 2. Subtract this, we are performing the operation R1 dash is equal to R1 minus R2. So 4 minus 3 is 1, 1 minus 1 is 0, 1 minus 1 by 2 is 1 by 2, 1 minus 0 is 1, 0 minus 1 by 2 is minus 1 by 2. So this is new row 1. So I will substitute here 1, 0, 1 by 2, again 1 and minus 1 by 2. Okay, see here the key element becomes 1 and elements above the key element is 0. Now let us find out the value of Zj. Zj is equal to 0 into 3, 0 into 1 is 0 plus 7 3s are 21. 0 into 0 is 0, 7 1s are 7, this is again 0 into 1 by 2 is 0 plus this is 7 by 2, again 0 into 1 is 0 and 0, again 0 into minus 1 by 2 is 0 plus 7 by 2. So these are the values of delta j. Okay, now find out the value of delta j, zj minus cj. Delta j is equal to zj minus cj. So that is, this is as it is. Now 7 minus 7, 0, 7 by 2 minus 6, take LCM, 2 is the LCM, 7 minus 2, 6 are 12, this is equal to minus 5 by 2, we are getting minus 5 by 2, again 0 minus 0 is 0, 7 by 2 minus 0 is 7 by 2. So the values of delta j are 21, 0, minus 5 by 2, 0 and 7 by 2. Okay, now identify, see whether all the elements in delta j row are positive. If all the elements in the delta j row are positive, then the optimality is reached. If it is negative, if there is any negative, identify the least negative, then the optimality is not reached, then again we have to go for one more iteration. So here minus 5 by 2 is the least negative value, that means the optimality is not reached, we have to go for one more iteration. So this is again, this is called an incoming column, incoming column. So the values are called incoming values, incoming value, this is called an incoming call. So that means x1 is an incoming value. Now therefore this is an incoming value, this is incoming value. Now find out the ratios. Again, what is the formula for ratios? The ratios is equal to, here ratios can be written as, so this is incoming x0 divided by x2. So the values of x0 is 1 divided by 1 by 2, this is equal to 2. Again 3 divided by 1 by 2, so this is equal to 6, and these are not required. Okay, now here identify the least positive. What is the least positive value? So the least positive ratio is 2, therefore this is called an again outgoing variable. So these are called as outgoing variables. Okay, so just here identify the least negative, and this is called an incoming variable, this is called incoming column. I didn't just find out the ratios. The ratios are x0 divided by x1, x0 divided by x2, 1 divided by 1 by 2 is 2, 3 divided by 1 by 2 is 6. Then identify the least positive ratio here. The least positive value is 2. So therefore this row is called an outgoing row. So here x2 is an incoming variable and s1 is outgoing variable. So in the next table, this s1 is replaced by x2. Okay, that's it. Hope you are following. Okay, so in the next iteration, this s1 is replaced by x2, and convert this key element. What is the key element here? 1 by 2. Convert this key element as 1 and convert the above element as 0 using the proper elementary row operation. That's it. And find out whether all the elements in delta j row are positive. If all the elements in delta j row are positive, then the optimality is reached. Identify the solution and find out the maximum value. That's it. Okay, now let us go to the next iteration, iteration number 2. So here in iteration number 2, so what are the first thing we are going to do? So convert the key element as 1. So what is the key row? We have, in key row we have 3, 1, 1 by 2, 0. Identify the key element. In the first iteration, identify the key element. Here, the intersection of these two rows, key rows and key column, will give the key element. So here key element is 1 by 2. Now in the next iteration, see here if all the values in delta j row are positive, then the optimality is reached. Since this is negative, minus 5 by 2 is there, therefore the optimality is not reached. Hence we have to go for one more iteration, that is iteration number 2. So in iteration number 2, for that table, the first important step is convert this key element as 1. For that, divide R1, this row 1 divided by 1 by 2 will give the new R1. And the next step is convert this element 1 by 2 again as 0. So convert the element below this key element 1 by 2 as 0 using a proper elementary row operation. Now let us convert this element as 1 by 1. So what are the elements of R1? New R1 is equal to R1 divided by 1 by 2. What are the elements of R1? R1 contains 1, 0, 1, 0, 1 by 2, again 1 and minus 1 by 2, 1 and minus 1 by 2, 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 1 by 2. So this goes to the numerator. This is R1 dash, 2 by 1 is 2, this is 0, gets cancelled 1, again 2 by 1 is 2, this is minus 1. So the new row 1 is 2, 0, 1, 2, minus 1. So this is 2, 0, 1, 2, minus 1. This element 1 by 2 as 0 by using the elementary row operation. R1 dash is equal to R1 divided by 1 by 2, that is 1 divided by 1 by 2 is 2, 0 by 1 by 2 is 0, 1 by 2 by 1 by 2 is 1, 1 divided by 2, 1 by 2 is 2, again minus of by of is minus 1. So substitute these values in the first row, that is 2, 0, 1, 2 and minus 1. Now for the second row, what is the elementary operation we are going to use? R2 dash is equal to R2 minus half of R1. So write down the elements of R2. What is R2 contains? Here R2 contains 3, 1, 1 by 2, 3, 1, 1 by 2, 0, 1 by 2. Okay. Now half of R2 dash means just multiply this by 1 by 2. So if you multiply by 1 by 2, this is like this. 2, 2 gets cancelled. 1. 1 by 2 into 0 is 0. 1 by 2 into 1 is 1 by 2. 2, 2 gets cancelled. This is 1. 1 by 2 minus 1 by 2. Minus 1 by 2. Okay. Now subtract this. If you subtract, what you will get? 3 minus 1 is 2. 1 minus 0 is 1. 1 by 2, 1 by 2 gets cancelled. 1 by 2 minus 1 by 2 is 0. Again 0 minus 1 is minus 1. While subtracting, this becomes of minus into minus plus. 1 by 2 plus 1 by 2 is 1. So therefore the elements R2 dash are 2, 1, 0, minus 1 and 1. I will write here 2, 2, 1, 0, minus 1, 2, 1, 0, minus 1 and plus 1. Okay. These are the elements of R2 dash. So see here, from the previous table, here the incoming value is x2 and the outgoing value is s1. So therefore this s1 is replaced by x2. So in the next table we are going to get this x2 and x1. The coefficient of x2 is 6, x1 is equal to 7, and the values of R1 dash is 2, 0, 1, 2 and minus 1 by dividing each and every element by 1 by 2, and the elements of R2 dash are 2, 1, 0, minus 1 and 1. By performing the operation, R2 dash is equal to R2 minus half of R1. Now just find out the value of delta j. Just multiply these two. 6 into 2 is 12 plus 7 into 2 is, that is equal to 26. Again 6 into 0 is 0 plus 7 into 1, 0 plus this is 7. Again 6 into 1 is 6 plus 0, it is 6. Again 6 into 2 is 12 minus 7. 12 minus 7, 12 minus 7, it is 5. Again 6 into minus 1 is minus 6, plus 7 into 1 is 7, minus 6 plus 7, this is equal to plus 1. Okay. Now just find out the value of delta j minus Cj. What are the values here? This is 26 as it is. 7 minus 7 is 0, 6 minus 6 is 0, 5 minus 0 is 5, and 1 minus 0 is 1. Okay. These are the values of delta j, that is Zj minus Cj. Now identify, check whether all the values in the last row are positive, greater than or equal to 0. If delta j is greater than or equal to 0, then the optimality is reached. See here, this is 0, 0, plus 5 and plus 1. So therefore the optimality is reached. The optimality is reached. So the optimality is reached. Hence the values of x1 and x2 are, these are the values of x1 and x2. So therefore x1 is equal to 2 and x2 is also equal to 2. x1 is equal to 2 and x2 is equal to 2. Okay. Now just substitute these values in the given objective function. So therefore since x1 is equal to 2 and x2 is equal to 2, the objective function is max z is equal to, what is the objective function? Max z is equal to 7x1 plus 6x2. 7x1 plus 6x2, substitute here 7 into 2 plus 6 into 2, 7 2s are 14 plus 6 2s are 12, that's equal to 26. So therefore Z max, the maximum value is 26 at x1 is equal to 2 and x2 is also equal to 2. So this is the maximum. So the maximum value is 26 at x1 is equal to 2 and x2 is equal to 2. This is how we are going to find the solution for this linear programming problem using simplex method. So the maximum value is 26 at x1 is equal to 6 and x2 is equal to 6. This is the procedure to find the solution of LPP using simplex method. Okay. Hope you followed this. That's all for today's session. Let us meet with a different problem in the next session. Thank you. Thank you very much.